Okay, in this section, chapter 2.5 is about solving absolute value equations or inequalities. So if there's an equation or inequalities, there are only three types as this. So first type is absolute value of x is equal to a. Then the solution is either positive a or negative a. Okay, so always make sure that absolute value is always positive. Absolute value of something is always positive. So we will let a is greater than or equal to 0. It cannot be a negative. If absolute value of x equals negative 3, then this one has no solution. No solution. Why? Because absolute value is always positive, cannot be a negative. So in this equation, we say no solution because we cannot find any x value whose absolute value is negative. So whenever this value a is non-negative, so greater than or equal to 0, then absolute value of x is equal to a, means the solutions are positive a or negative a. Positive a, this value, or negative a. Okay, the second type is inequality. Absolute value is this time less than a. Okay, then less than a, then this means the solutions are between positive a and negative a. It's between positive a and negative a. Between. Okay, so absolute value is less than, that means x is between a and negative a. X is less than a and x is greater than negative a. Okay, the third type is this. Absolute value is greater this time, greater. Then the solutions are separated. So x is greater than a, like this, or x is less than negative a, So we use or, right? Or there are two intervals. So x can be either in this interval or in this interval. So x is less than negative a or x is greater than a. So absolute value, when you solve absolute value equation, then the solutions x is either positive a or negative a. Okay, when we solve absolute value inequalities, so it is either less than, absolute value is less than, or absolute value of x is greater than. So if absolute value of x is less than a, then the solutions are between positive a and negative a. Between. So x is between positive a and negative a. So x is greater than negative a, and x is less than a. Okay, the third case is absolute value of x is greater than a. Then there are two intervals. So x is less than negative a, this interval, or the interval on the right, x is greater than a. So there are three equations and inequalities related to absolute value. Okay, then let's try examples. Okay, in this example, absolute value of x equals 10. Then x is what? Positive 10 or negative 10. Simple. Okay, next example, absolute value of x is 0. Then x is positive 0 and negative 0. So positive 0, negative 0 is same as 0. How about this? Absolute value of x is equal to negative 1. Then absolute value cannot be a negative. It has to be always non-negative, 0 or positive. So in this case, we cannot find x. So there is no solution. Okay, how about, let's try this one. Absolute value of 4x plus 5 is equal to 10. Okay, this is example number 1. Example number 1 in page 86. So the inside, the absolute value, So what's inside? The expression inside the absolute value symbol is 4x plus 5. So 4x plus 5 is equal to 10. Positive 10 or negative 10. So we have two equations. 4x plus 5 is positive 10 or negative 10. So from this equation, so this is case 1. And this is the case 2. So positive 10, negative 10. Then solve for x for each case. Minus 5 each side. For x is equal to 5. Divide each side by 4. So x equals 5/4. So we have one solution, or from the second equation, 4x is equal to minus 5 each side, then negative 15. Divide each side by 4. X equals negative 15/4. So these two values are the solutions. X is positive 5/4 or negative 15/4. Okay, let's try another example. Okay, number 2. This example 2. 3x plus 4, absolute value of 3x plus 4 is equal to 10. Then the expression inside the absolute value is equal to positive 10 or negative 10. So we can write two equations. 3x plus 4 is equal to positive 10 or 3x plus 4 is equal to negative 10. Then let's solve the equation for x. So minus 4 each side, and 3x equals 6. X equals, divide each side by 3, then x equals 2. Or from the second equation, 3x is equal to minus 4 each side, negative 14. Divide by 3, so x equals negative 14/3. So these two are the solutions. Okay, this inequality has absolute value expression like this. So just like solving an equation, we will isolate absolute value x on one side. So let's remove this minus 6. So plus 6 each side. Then 2 absolute value of 4 minus 3x cancel out is equal to 4. And this is 2 times absolute value of 4 minus 3x. So we can divide each side by 2 so that we can get rid of these 2. Then the left side of the equation is just a single absolute value. So absolute value of 4 minus 3x equals 2. Then use our standard method. Absolute value of something is equal to 2. So this expression is equal to 2 or negative 2. So 4 minus 3x is equal to 2, or there are two equations. 4x minus 3x is equal to negative 2. Then from the first equation, let's find x. So minus 4 each side, then negative 3x is equal to negative 2. Divide the equation by negative 3, so x equals positive 2/3. Or from the second equation, minus 4 each side, so negative 3x equals negative 6. Divide the equation by negative 3, then x equals positive 2. So the solutions are x equals 2/3 or x equals 2. Let's try another example. Another one. Okay, this is example 4. There are two absolute values. Okay, one on the left side of the equation, another one on the right side of the equation. Then how do we set up an equation in this case? Same thing. So get rid of all the absolute value symbol. So 3x minus x is equal to 7x minus 16. So here is case 1. So we have one equation like this, or the second equation is put negative sign on either left or right side of the equation. It doesn't matter. So I'm going to put the negative sign on the right side of the equation. Of course, remove absolute value symbol. So we can remove the absolute value symbol. Then there are two equations came up. One is remove the absolute value symbol from each side. The other equation is, case 2, is remove the absolute value symbol as well, but put a negative sign on one side, one of the two sides of the equation. Then solve for x. Okay, from the first equation, I will move 7x to the left, minus 7x, so minus 4x, minus 4 equals negative 16, plus 4 each side, then negative 4x equals negative 12, divide each side by negative 4, then x equals positive 3. Or, from the right side, okay, 3x minus 4 is equal to, the right side is negated, opposite, make the opposite of the right side. So negative 7x plus 16. So move negative 7x to the left, plus 7x each side. Then 10x minus 4 is equal to 16, plus 4 each side. Then 10x equals 20. Divide 10 each side. Then x equals 2. So from the right side of the equation, so from the second equation, we got x equals 2. And from the first equation, we got x equals 3. So the solutions are 3 or 2. Okay, this is inequality now. So when we solve an inequality of absolute value, the absolute value inequality, if the absolute value is less than, then always the expression inside the absolute value is between positive 2 and negative 2. So we can write x 5, put x minus 5 in the middle. So this expression, x minus 5 is less than 2, between positive 2 and negative 2. So from this, we can solve for x. Okay, plus 5, add 5 to all these three parts, then 3x7. So this is the solution. The graph, if you want to graph it, then x is between positive 3 and 7. Parentheses. There's no equal sign. So the end point is not included. Put parentheses. Interval notation is 3 to 7 and end points are not included. So use parentheses. Okay, let's try another one. Okay, how about absolute value is this time greater? Okay, example 35. Absolute value of x minus 7 is greater than or equal to 3. So if absolute value is greater than, the expression inside has two parts. It's greater than positive 3, less than negative 3. So we can write it like this. So the equation is inside the absolute value is greater than or equal to positive 3, or x minus 7 is less than or, and if there's equal sign, plug in plus, use the equal sign. So the expression is greater than positive 3, less than negative 3. Remember this one. Absolute value of x is greater than 3. Then this means here is positive 3, here's negative 3. So x is greater than positive 3, less than negative 3. So this will give you x is greater than positive 3 or x is less than negative 3. So the expression inside the parentheses, inside the absolute value is greater than the positive, less than the negative number. So x minus 7 is greater than the positive 3, less than the negative 3. And equal sign, put the equal sign because the original inequality has equal sign. Then solve for these two inequalities. So add 7 to each side, then x is greater than or equal to 10. So we have one solution. From the second inequality, plus 7 each side, then x is less than 4. So x is either greater than or equal to, I will use bracket, equal to 10. or here's 4, x is less than or equal to 4, bracket on number 4. For interval notation, negative infinity to 4. 4 is a bracket because there's equal sign. 4 is included. Or, okay, or for the or, we can use the union symbol. And from 10 is included all the way to the right, infinity. So this union symbol means or. So when you put two intervals together, we can put these two intervals here and here. So we'll use U. Okay, U means or. So we can write the solution using interval notation like this, or inequality notation like this, or graph notation like this. Okay, this time let's compare these two examples, inequalities, number 51 and 52 on page 19. Okay, this one is the absolute value. I don't know what the expression is, but absolute value is less than negative number. You know, the absolute value is always greater than or equal to positive number, greater than or equal to 0, greater than or equal to 0. It cannot be a negative. Even it cannot be, absolute value cannot be less than negative. Even it cannot be equal to negative. So in this case, there is no solution. So just like this. Let's say absolute value of x equals negative 1. This one has no solution, right? No solution. Because absolute value cannot be a negative number. Even the absolute value is less than negative 1. Of course, this has no solution. Even absolute value even cannot be a negative number. So it cannot be also less than negative number. Okay, so this is kind of tricky. So if you understand the definition of the absolute value, then you will see why there is no solution. How about this? Absolute value is, I don't know what this expression is, but absolute value is greater than negative 3. Of course, absolute value is always, this one is always greater than or equal to 0. And 0 is greater than negative 3. So, this is always true. Always true. The inequality is always true. So, x can be any real number. So, x can be any real numbers. So, there are infinitely many solutions. So, we can say that all real numbers, so all the values in the x, the number line x, is the solution. Okay, so these two are very similar, but the first inequality has no solution because absolute value cannot be less than negative number or cannot be equal to 1. So this has no solution. But since absolute value is always greater than or equal to 0, and 0 is always greater than negative 3, this absolute value is always greater than negative 3. No matter what the x value is, always greater than negative number. So the solutions are all real numbers. All real numbers.